Hi and welcome to the Unit 2A.1 video. This video is for those who missed class on Thursday, September 24th, or if you were in class and you just sort of want to see what we learned again. So we're starting Unit 2A, Electrons and Electron Configuration, and the essential question for this unit, which subatomic particle is most important? Now we know that there are three subatomic particles, protons, neutrons, and electrons. And we know some of the important qualities of each. For example, the protons identify the element. Neutrons are responsible for the strong nuclear force, or nuclear strong force, that stabilizes the nucleus and contributes significantly to its mass. And electrons, when removed or added, gives an atom its charge. So those are some of the things that we know about the three subatomic particles. So in this unit, we're going to explore electrons a little bit more because in Unit 1, we focused mostly on what was in the nucleus, so the protons and the neutrons. So we're going to learn more about the electrons to sort of help us answer that essential question. Now, in this first lesson for this unit, we're going to learn how electrons are arranged in the atom. And there are two types of arrangements that we're going to look into. We're going to look into the Bohr model, which you've seen before, and electron configuration, which is likely new. Now, one thing I want to note is that both of these electron configurations or arrangements, the Bohr model and electron configuration, are of the same isotope, nitrogen 15, and it's a neutral nitrogen 15. Okay, so let's take a look first at how we draw a Bohr model. Now, for some of you, this may be review because Bohr models are quite popular, particularly in middle school when folks are learning about atoms. So if this is review, great, but I'm going to go over some key things, and then we're going to see the limitations of a Bohr model. All right, so here are the steps for drawing a Bohr model. The first thing you want to do is determine the number of protons, neutrons, and electrons. Then you want to draw the nucleus, and you're going to, inside the nucleus, you're going to put your protons and neutrons. Then you're going to draw shells and fill those with the electrons. So when drawing the shells, the number of shells you need will be equal to the row or period in the periodic table. I'll show you that in the example. And then you fill the shells from inner to outer. And the first shell, it maxes out with 2, and then the second shells are higher, you're going to max out with 8. So those are some general rules. We're going to see that doesn't quite always work, but it will work in most of the cases that we will see here. Okay, so let's get started. Here in this first example, we have Beryllium 7, and we want to first determine the number of protons, neutrons, and electrons. So now, starting with the number of protons, we're going to use that atomic number, which is the bottom number, so that means we have 4 protons. For the neutrons, remember, we're going to take the top number, which is the 7, and subtract that by the bottom number. So the mass number minus the atomic number, right? Top minus bottom. And that'll give us the number of neutrons. So 7 minus 4 is 3, so we have 3 neutrons. Now for the electrons, we have to look at the charge. And the charge will be what's written in the upper right side of the symbol here. Now since there's no number written here, then we know it's neutral. So the charge is 0. So what does that tell us? That tells us that the number of protons and electrons must be the same. So in this case, we have 4 electrons. Okay, so that was step 1, determining protons, neutrons, and electrons. And we then now need to draw our nucleus with the protons and the electrons. So I'm going to go ahead and do that. In the center here I have my nucleus. I have 4 protons and I have 3 neutrons. So inside the nucleus we put our protons and our neutrons. Now, the next step is to draw our shells. And what we're going to do is we're going to use the periodic table to determine how many shells we want to draw. So to do that, you find beryllium in the periodic table. Here it is. Notice that it's in the second row. So this is the first row going across, that's the second row. That means we need to draw 2 shells. So that number on the side of this periodic table tells you there's period or row it's in, and we're going to draw 2 shells. Okay, so 1 2. All right, the next step is to then fill the shells with the electrons starting from the inner to outer, and make sure that the first shell maxes out with 2, and then the rest you can max out with 8. So since I have 4 electrons here, my first 2 I'm going to put in the first shell. Now since I'm filling up the shell with 2, I put the electrons paired together. I had 4, I used 2 electrons, I've got 2 more to put in. And then in the last shell, since it does not fill up, make sure that you put 1 in each corner. It doesn't matter which direction or where you start. So 1 goes in each corner before you double. And that's the Bohr model for beryllium. All right, let's try this now for fluorine. So again, we're going to find number of protons, neutrons, and electrons. So protons is equal to 9. It's that bottom number, the atomic number. Neutrons is going to be the top minus the bottom. So that will be 19 minus 9. It gives us 10. And then the electrons, in this case, we have a -1 charge. So this -1 charge tells me I have 1 more electron than I have protons. And so the answer to that would be 10 electrons. Now the other thing that you can do to calculate the number of electrons is to do the number of protons minus a charge. So 9 minus -1 will give you, again, 10. All right, so I have my number of protons, neutrons, and electrons. Next up, I'm drawing my nucleus. Put my protons in, so 9p and 10n. Put my neutrons in. Now I need my shells. I find fluorine in the periodic table. So here's fluorine. It's in the second row. Remember, rows go across. 1, row 2. So I have to draw 2 shells. Now I have 10 electrons to put in. The first shell gets my first 2. So I start inner, outer. 1, 2. I've got 8 more. 1, 2, 3, 4. Remember, give each corner 1 before doubling. 5, 6, 7, 8. Okay, so this is the Bohr model for fluorine. We'll do one more example together, and then I'll have you try the examples that are below. All right, last example is sodium. So we're going to start, of course, with our number of protons, number of neutrons, number of electrons, 12 protons, 23 minus 12, 11 neutrons. And the electrons here, because I have a positive charge, I have more protons than electrons. So the number of electrons I'm going to have is going to be 1 less than 12. So I have 11 electrons. Nucleus, 12p, and 11n. Oh, number of shells, I forgot. I got to count those, right? So for that, I go to my periodic table. Sodium is in the third row. So I need 3 shells for that. Okay, so let's 1, 2 go in the first one, and now the next one, 1, 2, 3, 4, 5, 6, 7, 8. So I've got 10 so far, and I've got 1 more to put in. And there we go. Oh, and I think actually this one is supposed to be magnesium. Sorry for making this magnesium. There we go. Not sodium. And the reason why I knew that wasn't right was because sodium doesn't have an atomic number of 12. Magnesium does. So that's magnesium. Okay. All right. So that is that. Now what you're going to do is you're going to try these 3 here at the bottom. Oops. I want you to see those. So on a separate sheet of paper, write these down, and then try to draw their Bohr models. And when we come back together, I'll show you the answers. Okay, so here's what you should have for the first one. Notice that that one doesn't have an electron in the shell there because we removed the 1 electron. That's what you have for the second one. 2 in the first shell and 8 in the second and third shell. The next one looks similar, 2 in the first shell and then 8 in the second and third shell. Now for the last part, for the iron, this is what you may have. You may have something similar. This time you have 4 shells because iron is in the 4th row. And you may have 2 in the first shell and then 8 in shells 2, 3, 4, and 5. Oops, sorry. So you may have 8 in the last shells. But it turns out, and this might shock you, that this is completely wrong. That's not it. And this highlights the fact that the Bohr model is limited. This is actually what the Bohr model looks like. So you would have 2 in the first shell, 8 in the second shell, 14 in the third shell, and only 2 in the fourth shell. So now the question is, well, why? Why is that? Well, it has to do with the fact that the third shell can actually fit 18, not 8. And the fourth shell can fit more than that. It can fit 32. So this Bohr model is limited using those rules. What we need to know in order to figure out the new rules are electron configurations. And that's what we're going to cover next. So remember, we're looking at 2 ways to describe the arrangement of the electrons, Bohr model, electron configuration. We're going to do the electron configuration next. What I'm going to do is I'm going to start the electron configuration in a separate video. So if you want to see this part, watch that second video. Have a quality day, folks.